So, hello everyone, welcome back to my YouTube channel. Today we are going to solve the problem 283, which is move zeros. So, let's quickly read the problem statement. Here we are given an integer array nums, and our task is to move all the elements, all the zeroth elements in the end, and like maintaining the relative order of non-zero elements. So, yes, let's quickly check it. The input here is 0, 1, 0, 3, 12. So here the nums which is given in 0, 1, 0, 3, 12, right? So our task is to move all the zeroth element in the end and maintain the relative order of non-zero elements. So the answer will be here 1, 3, 12, 0 and 0, right? So how we can approach this problem? So first approach is like just divide this problem into two sub-problems. First is to just count the number of zeros, how many zeros are there in this array, and just traverse again and push the non-zero elements in the another array. So let's quickly see it, how we can do this. The first iteration of this nums will be like this. We will just count the number of zeros. We can do this count zeros equal 0 in the starting, and we will traverse from I equal to 0 to n, and we will just count the zeros. If the ith element of array is equal to 0, then we will just count zeros plus plus, right? And just take a vector array, right? So what we are doing here is iterate this nums array again. When we will iterate this for I equal to 0 to n, and we will at the time when we will iterate this again, what we are going to do here is, if the element is non-zero, if the element if the nums of I is not equal to 0, right? If it is not equal to 0, then what we are doing here is just push back the element in the answer array, right? Just push back that element in the answer array. Then when we have pushed that element in the answer array, so we have the count of 0, right? So in this case, what we have done till now is, in the answer array, what we have 1, 3 and 12, right? So what the things are left 0, 0. So we will just run a while loop again to push those 0th element here, right? So like count of zeros, count minus minus the number of zeros, like how many the number of zeros will be, the loop will be run in like till that, and just push back those zeros in the answer array, and at the end simply do nums of I, simply do nums equal answer of, because in this problem we are not going to return anything. We will have to just update this answer array based on the required conditions. So yes, this is the first approach. Let's quickly see how we are going to implement this. So let's quickly define, like let's quickly count the number of zeros in the nums array. Take a variable, count the number of zeros in the nums array, right? And iterate in the nums array to, and if it is equal to 0, then what we are doing here is simply count zeros plus plus, and let's define that count variable. Right, so we have the number of zeros in the nums array. Now what the task is, iterate over the nums array and push the non-zero elements in answer array. So let's quickly define that answer array. So here we have an answer array and iterate over the nums array again, and what we are doing here is if it is not equal to 0, simply push that element in the answer array, right? And now what our task is, we have now answer array as 1, 3 and 12. So what the task is left to push those 0th element also. So we will just run a while loop till time count zeros. So here in this case the number of zeros are 2. So the loop will be run in like 2 times, right? So simply push the zeros in the answer array, and at the end nums equal answer array and return no, don't need to return anything. Let's quickly see. So yes, so finally it is accepted. Let's quickly see the time complexity and space complexity of this solution. So see, here we are using a vector array to store the elements. So the space complexity will be order of n. And as we are iterating over the nums array twice, so the time complexity will be also order of n, right? So can we do better? Can we do better? Yes, obviously. So what is the better approach than this one? Let's try to find that. So here we can see a better approach, which is two-pointer approach, right? So what we are going to do in this approach is, as you can see that we are given an input array as like 0, 1, 0, 3 and 12, right? So yes, in the two-pointer approach, we are just going to take two indexes. Here in the initial position of the indexes will be the 0th element of the array, and then we will iterate over the array, and whenever we will find one non-zero element, we are just going to swap that element from the index. Let's quickly take a look how we are going to do this. So we are just going to iterate. Firstly, I and j both will be at 0th position, and then we will iterate if nums of j is not equal to 0. If it is not equal to 0, then what we are going to do here is just swap nums of I to nums of j. right? Just swap nums of I to nums of j. And if it is 0, then do nothing, simply move that j plus plus. So let's quickly take a look. So here we will run a for loop in this manner. Just take two indexes, I equal to 0, j equal to 0, and till that time j should be less than n and j plus plus, right? So this loop is like there are two indexes I and j. Both in the initial position will be in the for, like first element of that vector array. And when we are iterating through this way, so if that nums of j is not equal to 0, right? So what we are going to do here is simply swap the nums of I and nums of j, right? So this way we are just like when we will iterate, so first iteration will be like 0, or it is like the condition will not be satisfied, so we will just move to the first, like this is 0 1 2 3 4, so we will move here j is equal to 1, and like it is not equal to 0, so we will simply swap. So 1 will be here, I equal to 0 that time, and after swapping we will simply move I also, right? So I was here, now I will be here, right? And then j will be here. It is not equal to 0, no, it is equal to 0, so we will do nothing, simply move here. So now j is equal to 3, and it is not equal to 0, right? It is not equal to 0, so we will simply swap 3 and 0. So 3 will be here and I will be here, so it is now 2, right? And j is 3, so yes, now we will move next. So j will become 4. It is not equal to 0, yes, it is not equal to 0, so 12, we will just simply move that 12 here, 1 3, and in this position, ith position 12 and 0, and we will simply swap this and this, so 0 will be here, right? And now the position of ith will be this one, right? Third one. So by this way we are just going to achieve the non-zero element in the front of the array and zeroth element in the last of the array, right? Let's quickly see the solution. So what here is, simply take a n nums of size, and we are just iterating over the array, right, till the time j is less than n and j plus plus. What we are checking here is if nums of j is not equal to 0. If it is not equal to 0, then what we are doing here is simply swap the nums of I comma nums of j and simply I plus plus. Let's quickly run this. See, it is accepted. So now you can see the space complexity is reduced because we are not going to take the extra vector space, right? So in this case, the space complexity will be order of 1 because we are just iterating the given array, and time complexity will be order of n because we are iterating the array once, right? So this is the better approach than that one. So yes, I hope you guys have enjoyed this video. If you have got some knowledge, yeah, like how to approach this problem, then please make sure to like this video and subscribe my channel. I am just going to upload these videos very frequently. So please support. Thank you so much for watching. Have a good day.